and get back to sharing again. Right, so hopefully you can see this. Right, so as I was just saying, today we're going to talk about running generative AI on your desktop. So the first question is, why on earth would you want to do that? So we'll cover that. And I'm asking you to bear with me for the first few slides because I'm going to talk about generative AI models, hardware, inference engines, and then I've got a slide bringing it all together, and hopefully that will get everything clear in your mind, how it works. And probably at that point, I'll open up for any questions so far. And then we'll go into demos, um, running large language models on the command line, a few different ways, graphically, and also diffusion models and generating pictures and some bits and pieces at the end. So first question is, why on earth would you want to try and run these huge complex systems on your desktop? Well, probably number one is going to be privacy. So, for example, if you've got the problem you want to ask a large language model to summarize your financial position, what you could do is get all your bank statements in PDF formats, upload them to ChatGPT and get a nice summary back. But then, of course, you're exposing all your financial stuff to the cloud, and really you don't necessarily know what's going to happen to that information that you've voluntarily given this server. So privacy is one good reason. I didn't put this down here, but another reason is if you don't have a stable internet connection. So last night, for example, my internet connection failed for a few minutes and I had some automations that failed. So, these days we are so dependent on having a stable internet connections, we kind of forget that they can go down. And so if you run these things locally, if your internet connections goes down, it doesn't matter. Yes. So another one is cost. So you can go online and get access to actually quite a large range of various generative AI systems free of charge. But these free plans tend to be limited in some ways. And if you want an unlimited plan to get the very latest model at the latest speed, you're going to spend, I think OpenAI charge between $20 and $200 a month. So that can matter. If you need it, then use it and pay the money. But maybe you don't. Maybe you can just run this all locally instead. Power consumption. So if you're concerned about these very large systems with very large models consume a lot of power, running these models locally means you'll be running smaller models and they will be more efficient than the big models running up in the cloud. And of course, we mustn't forget one of the main reasons I like to do it is just for fun, to tinker, to play, to toy around. Let's not forget that. It's just kind of fun to do and have a play. Of course, sometimes you want to do things that you can't do online. In my talk about how generative AI works, I've got a demo of guardrails. And so guardrails are part of the large language models which stop you asking, maybe illegal questions. And so what you can actually do in a demo situation, you can play with these large language models locally and you can edit them and remove the guardrails and actually show how these models will behave without these guardrails. And of course, there's lots of specialist models available, which you may not be able to get on a cloud type system. But now here's the thing. So compared with the cloud providers, OpenAI and stuff, your local hardware is likely to be much, much smaller. I've got a Apple MacBook here, M1 MacBook, which is reasonably powerful, but it's not nearly as powerful as the servers in the cloud. So with limited hardware you get at home, you're only likely to be able to run small models, and we can talk about that some more. And of course, small models They're going to run faster locally, but they're going to be less accurate. So in practice, if you're going to play with this stuff, you're usually in the game of trying different models. Some will work, others won't work. Different settings, have a play, try and find out what works best for you for the problems you're trying to solve yourself. So let's talk about models. And I said in the introduction, we're going to talk about a little about models, inference and stuff, and then bring it all together. So bear with me a little bit on this and it'll make sense in a few slides time. So there's different types of models. Now, if you remember from the generative AI talk I've done, a model is really a file which contains both the design of the generative AI system, what layers in neural networks it's got, and also the values of all the parameters, all the weights, and so on. So after training, the guys who've done the training can actually save that as a file, put it on a server somewhere, and then you can download that file and actually run it locally. So there's a few different types of models you can actually download. Large language models, which produce text. So very much a chat GPT scenario. You type a text in, you get a piece of text back. And now these can be multimodal. So large language models can be trained on text only, in which case you can type things in and get text back. Or they can be multimodal, which that means they're trained on more than one type of data. So for example, text and images. And if you've got a multimodal large language model, you can then show it a picture and ask it to describe the picture or identify the animals in the picture and so on. Another feature of these large language models, which we don't tend to talk a lot about, is called the support of tools. Now, tools is something an add-on to large language models, usually just written in Python, which can actually get your model to do something in addition to what it's trained to be. So, for example, you could get it to query the internet. You could get it to link into your home automation system and get it to turn on your lights and so on. So building these tools. Now, not all large language models support tools. Some do. And if you want to, integrate into your home automation, you'll want to choose a model that supports tools. One thing which I'm not going to demonstrate today, but I'm going to mention it because it could be an interesting thing to try at home. There is a design of a model called a mixture of experts. So instead of having one big neural network that solves all the problems you're going to throw at it, a mixture of experts is like one model that contains several different neural networks. So perhaps you could have one model that's good at maths, another model that's good at languages, and so on and so forth. And so if you run a mixture of experts model, what happens is you type your text prompt in, the right model is chosen, and then that runs your query. So you could get a mixture of experts, which is actually quite a big model, but because you're only running a small part at a time, you can actually do quite good results this way. There's another type of model, not a large language model, called a diffusion model, and they produce images. And I've never really described how this works, but in essence, diffusion model starts off with a picture of random noise and then goes through several frames where the random noise gets more crystallized and more details until it comes out with a kind of useful picture, hence the word diffusion model. But we will look at that today. Now, availability of these models. So the big guys, right? Google, OpenAI, they're going to spend billions and months training their massive models, and they're going to keep those secret typically. However, many people, including the big guys, release some of these models with some sort of open source license attached to it. In other words, you can download them. So Hugging Face is one of these places on the internet which holds models. So people like Google, they will spend millions, billions training their, say, Gamma 3 model. The big Gamma 3 model they'll keep proprietary, but the smaller ones, they're quite happy to publish on Hugging Face so other people can download them and run them locally or improve them or extend them or add tools to them. So Hugging Face is the place to go to find such models. We'll have a look at that in a minute. So if you go onto there and you try to download, lots of them are just free. You just click and download the files. Some of them require a license, a free license. And models from Google, you have to say, I'm not going to use this model for commercial purposes. And models from Meta as well, you have to say this, you're not going to use it for commercial purposes. But it's free to download, not quite open source, but sort of like nearly. Now these models are got sizes. So you can get some very small models, some very big models. And the main way to measure the size is number of parameters. In other words, number of weights that these models have got, which are just numbers. If you remember from the generative AI, how generative AI talk works, you've got an individual neuron that takes inputs, and each input is multiplied by weights, and you get a summation and activation function. These weights is actually the configuration of this large language model. And so small models have small numbers of parameters, big models have large numbers of parameters. And you can get them with, 1 billion parameters, hundreds of billions of parameters. The big ones that you can only, run under, OpenAI or Google Online, they are getting into the trillions of parameters now. Now, I'll give you a guideline now. My desktop here, which is a MacBook, can run models up to about 8 billion parameters or so. Just give you a feel for that now. The other thing is the context size. In other words, how big of a chat window can you use? Now, if you're just using it for simple things at desktop, you don't really need a big context window size unless you're trying to analyze, lots of PDF documents and so on. Now, quantization. This is an interesting thing that you'll need to know something about. So I just said that individual neurons in these large language models have inputs, and each input is multiplied by weight, and then all those are added together, and you have an activation functions. And we can choose the accuracy of how these sums are done. Are they, 32-bit floating point multiplications? Are they 8-bit? Are they 4 bits? And this accuracy of these mathematical computations inside the model is called quantization. So models that have high accuracy and large number of parameters also are storing numbers in, perhaps 32-bit fields. Smaller models that you can run locally may get 8 bits or 4 bits, and you can get those to run quite successfully locally. So simpler maths is used to speed up, but a little bit less accuracy. And this is where you probably want to play around a bit. You might want to try a model with like 8 billion parameters and quantize to 8 bits and then quantize to 4 bits and see if one's more accurate than the other. There's a lot of playing around with this. And also models have different file formats, unfortunately. So we've got GGML, which comes from OpenAI, which is GPT generated model language. We have GGUF, which is a unified format. We've got PyTorch, which is specific to the Python torch. We've got safe tensors, which comes from Stable Diffusion. So you go onto Hugging Face, you can get files on these different formats, but you can usually convert between them. So don't worry too much about those. You might have to do some conversions locally. Right, bit more on Hugging Face, and don't worry, we're going to bring all those bits and pieces together back in a minute. Stick with me. So Hugging Face. I'm going to switch to Hugging Face website. Hopefully you can see this. So this is Hugging Face. Um, and if you want to search for models, huggingface.co is the rest. You can click on models. And here we got 1.7 million models you could possibly download. It's a lot of models. And you can do a search, Gemma, Bray, whatever.
Peter, are you displaying this?
I should be. Are you not seeing it?
We're seeing you.
Oh, that is interesting. Thank you for letting me know. I thought
I had the presentation as well.
I
On two screens.
I saw it. Okay.
Me too.
Yeah, it was viewed for me, but
That's it.
is that working?
That's got it. Yeah.
Okay, so you should see a browser and you see a bit of my backdrop as well. Yeah, so this is Hugging Face, and you can search for Gamma or whatever you want to do. You can click on them, and Hugging Face gives you a lot of information about the model, what inputs, outputs, how to use it, a bit of Python code if you want to use it. And very often they'll give you some, I don't know if this one does, some benchmark results. So if you're looking for a model to do language translation, for example, you want to go on to Hugging Face and do a search and find a model which is good for language translation. Oh yeah, there's multilingual results. And then you can click on files and versions, and you can actually download the actual physical models there. So that's Hugging Face. The problem with Hugging Face, it's designed for experts. It's got lots of interesting information on there, lots of details, but there's 1.7 million models for you to sort through. So hopefully this goes back into full screen mode for you again. So that's Hugging Face. I find it better if you're looking for models to either go to llama.cpp or Ollama. And I'll switch that in a second because that gives you a boil down, a much smaller list for you to look at. So let's have a look at those websites. Hopefully we're still sharing my desktop. So this is llama.cpp. I've got these references at the end. We'll see in a minute, llama.cpp is like the godparent, if you like, of running large language models. It's the original, and people still say the best. So this is where you get this from, and you can scroll down here, and it's got a list of models that work with llama.cpp. And it's a much smaller list. It's kind of a bit easier to digest. So you can have a look at these models. And the other way to find models is Ollama. Ollama is another way to run large language models, and we'll demonstrate this in a minute. Here I've gone to ollama.com. You can click on models. And I usually sort by newest. And you can see the latest models here, update 5 days ago, Gwen 2.5. You can click on there and we can see different models, different sizes you can use. This one's multimodal, also supports vision. It's got a description of it. So both Ollama and llama.cpp are good sources to find lists of models that you actually might want to use. And here, for example, on Ollama, you can see this Gwen 3 actually supports tools. So it's a nice, on this one I've got tools and vision here. So let's go back to our slides. I'm getting to this point where we can bring it all together, I promise. Right, so that's models. Downloading and converting, I'm not going to spend too much time on it, other than to say you can do this if you really need to. So you can browse Hugging Face and download your model, but some tools, in fact, most tools will do the downloading on your behalf. Or you can run, command line tools on your desktop to download them and you can convert them. So you can do this. So don't worry about the file formats too much. You can convert them locally if you want to. But the chances are if you need a particular model in a particular format, the chances are quite high you can go to Hugging Face and find someone who's already done the conversion. Now, last slide before we kind of bring all this together, hardware. If you're going to run generative AI locally, you really got to understand what hardware you've got. Now, one thing we'll see quite a lot when you're looking at hardware is this very simple tera operations per second tops. It's a bit like MIPS, or it's a very crude measure of how fast your hardware can execute a large language model. So the more tops, the better, the faster your model can run. It's a simplistic measure, but it's in the ballpark. But there's more to tops that affects the performance of your model. How much memory is available to your model. Now, this does matter in some cases. So, for example, if you've got, I'll cover this, I'll summarize in a minute. Yes. So your desktop will have a CPU in it, a central processing unit, and you can use that to run your model. It may also have an NPU, a neural processing unit in it, and mine does, my desktop does. And of course, that is a way that these tools can get your model to run faster. So my desktop, this one here, under the covers, it's called Metal. The word metal is an Apple term, and it refers to both the graphical and neural processing unit on my desktop. So when I run tools, I want to know that they're actually making use of all my hardware, and I'll be looking to see if it's actually using metal. And I'm going to have another demonstration of something different, which is a single board computer which has got a rock chip, like a Raspberry Pi style device, but we'll get to that. I've got one just in front of me here, which I'll show you, and that runs 6 tops, so it's about half the speed as my desktop. AMD Ryzen, somewhere around 16 tops, so that's going to be faster. And this is an interesting new device that came out, and I think it's like plugs into a little USB socket, and that does 40, so that's pretty fast. These days, because these models tend to run slowly, there's a lot of effort going on to optimize them to hardware. So we'll end up seeing some tools that can run large language models that uses a combination of your CPU, your GPU, your NPU. For example, the Intel Meteor Lake can combine these and get 34 tops. Now, the high-end guys, the NVIDIA, you can spend a fortune on these GPU, these cards designed to accelerate graphics, but are also good at running generative AI tools, things like NVIDIA, and you can get ridiculous speeds out of these. Now, of course, the big guys, OpenAI and Google, Meta, and so on, have server farms full of these NVIDIA devices, and they spend billions trying to buy the last remaining card from Amazon or wherever they get them from. But as you can see the difference here. So the clouds are going to be, way running faster. Your desktop is likely to be in this sort of level down here. Lastly, before we bring everything together and we'll open it up for chat so far, is inference engines. Now, an inference engine is how you run these models. So you download these models, hopefully of the right size and characteristics that you want. Then you start your inference engine. Your inference engine is going to load the model and actually starts running the large language model for you. So an inference engine runs large language models. And as I said before, the big one, the grand person of this field is llama.cpp. And you'll find a lot of tools will simply embed llama.cpp in it. You can go and buy a tool or download a tool which claims to run ChatGPT locally, and it'll give you a nice pretty screen. And inside it, it will just be running llama.cpp. So it's one of the very common work engines. It's open source. You can download it. It supports Mac, Windows, Linux, wide, and it supports a large number of CPU types, NPU types, GPU types. It'll auto detect them. Another very common way to run large language models is OLLAMA. It's a little bit newer to llama.cpp, and to be honest, it's taken a lot of ideas from llama.cpp, is OLLAMA. And that's my favorite, to be honest. This one seemed to be, it works better. It's got more user-friendly features, if you like. And today I'll also be demonstrating RKNN-LLM, which is specific to Rockchip. So this is not a general purpose inference engine like these two are. It's specific to some hardware. And there are others, but Llama and Llama seem to be the most common ones you see. And to run diffusion models will generate pictures. We can use stable diffusion.cpp open source program you can download and run. And instead of loading and running large language models, it will load and run diffusion models. And there's one which I'm going to demonstrate today called Automatic 1111. I don't know why it's called that, but it is open source. It can run these diffusion models to generate pictures. And there are others. And user interface, these tools that I've mentioned are command line only. So you can run them, you can type in your prompt and see your responses back. But we need to go beyond that and get a graphical interfaces. So there is a graphical interface built in to llama.cpp, and I'll show you that. But there is a general purpose user interface called Open Web UI. And that can speak to Llama, it can speak to OLLAMA, it can speak to Automatic, it can speak to the internet and so on. So this is very much a general purpose user interface. And as I said before, there's many native apps you can go onto. I don't know, the Apple Store and say, I want to run ChatGPT locally, and you can download a binary, and you can see a nice window, and you can type in your prompt. It will probably be running llama.cpp under the covers. Right, so this is a slide where I'm putting all those bits and pieces together. I know it's a bit confusing so far, but after this, I'll pause to see if there's any questions so far. So putting all together, so we've got our hardware, and you're going to have a central processing unit on your desktop or your tower. I've got Metal, which is the accelerations which Apple provide, which is a GPU, NPU. You might have an NVIDIA card in there. You might have a Radeon card. You might have a Rockchip. Whatever it might be, you should really understand what you've got so that when you run these tools, you can make sure it's making the best use of the hardware you can. And we can run llama.cpp. And llama.cpp will, interrogate your hardware and find out what it needs support. You can download models, you can pass it to llama.cpp, and one too many. And you can fire up a simple web browser to llama.cpp. You can type in your prompt and get a response back. But better, I would argue, is to use a more general purpose user interface called Open Web UI, which is open source. And this is nice because it can talk to many different types of models, and it supports tools. You can do web searches with it and so on and so forth. So this is what I'll be running today as a demo. My hardware is going to be my MacBook, which uses Metal. I'm going to start off running llama.cpp. I'm going to load a model. I'll run its native UI, so you can see that. Then I'll fire up this more general purpose web UI and we can see what that looks like. So you'll be running, or I'll be running two programs, llama.cpp, Open Web UI, and I'll be using my Firefox browser to interrogate that. Hopefully that's clear. We can do more though. We can run Ollama. Ollama will look at the hardware and do that. Ollama will load models. Ollama is also supported in Open Web UI, so we can use the same front end, depending on whether we want to use Llama or Ollama. And of course, we can run diffusion type models as well. We can run automatic on one with its models, using the same hardware, but using the same user interface. So we can go into the browser, we can run large language models from Llama and Ollama, and we can ask automatic to generate our pictures. Now, I've said this a few times, you can download native apps like GPT-4All, Mac.ia, Witsi, LM Studio. There's lots of them around. And what they are, they're native apps that just simply bundle these tools in for you. Of course, there's less to download, less to use, but this is the computer forum, so we want to make it complicated. Now, Open Web UI can also talk to cloud devices. It can do internet searches for you and pass the results down to your model. It can, what else? It can run ChatGPT. If ChatGPT is running in a cloud, you can use your desktop browser to connect to it. And the reason this works is there is a common way to interface to these tools that run models, and that's called the OpenAI API. So Open Web UI supports this, as does llama.cpp, as does Ollama, as does Automatic, and so on. And because they talk a common language, these components, you can plug them together and actually get them to work. And I mentioned this before, there is a thing called tools. So these are add-ons to large language models to do other things. So for example, search the internet, or interface to your home automation system. And that can either add information into the model or get the model to do some behavior based on your request. So I'll pause there. So I know I've gone through each of these parts, tried to glue them together. The rest of the talk is going to be mostly demos. So is there any questions so far what we're trying to achieve here? We're going to run these inference engines locally. They're going to make use of the hardware, and we're going to run OpenUI to have a nice interface. Peter, you have to unmute yourself. Yeah.
Okay, thank you. What chip does the Pi accelerator use, please? Is it Rockchip?
Oh, so these little single board computers, I've got one just in front of me. I'll show you when we get to there. Raspberry Pi was one of the original ones, and they all have a CPU instruction set which is based on ARM, which is actually exactly the same as your phones. Your phone's going to have an ARM chipset in. My MacBook's got an ARM chipset. Raspberry Pi's got an ARM chipset, but you can actually buy fabrications from different manufacturers. And my Orange Pi here has got a Rockchip chipset, and I really don't know what the Raspberry Pi has got in. It may be Rockchip, it may not be. Sorry, don't know.
I think the actual chip itself is Broadcom. But what about the actual extra thing you can buy, which plugs into the Pi? Is it on the, what's it called?
Yes, there is a plug-in board for the Raspberry Pi. And that, I believe, from memory, can do about 10 tops or something like that. And
that's
these,
not bad.
yeah, so it's not too bad. It's a bit less than my desktop, but not too shabby.
But for 70 quid, that's not bad, is it?
Yeah, exactly. Yeah.
Okay, thanks so much, Peter. Thank you.
Alan.
Yes. So when these large language models say they support vision, so like Gemma does,
Yes.
are they using diffusion within the model?
And so a large language model that supports vision means you can type in text and it will reply, but you can also send it an image and ask it to describe the image or find the objects on that image. Large language models do not generate images, they can process them as input though.
Right. Okay. Gotcha. Thank you.
Alan,
Oh, hi. When you download these files, how large are they, and do you need a high-speed internet, or and can you download lots of them?
yep, you can certainly download lots of them and I'll show you. Okay, so this is, let's tell you what, let's go to Hugging Face. Hugging Face. And I don't know if you can see this, but this is Gemma 3, which is a 4 billion parameter, and it's 5 GB.
Okay, that's fine. No problem.
So, if you got reasonably fast, it'll download in, pretty quickly.
And a subsequent question: if you download various models, can you get them to? Can you in some way choose the best model for the question that you want to answer?
Yes, hold that question, and I shall be demonstrating that.
Okay, thanks.
Neil.
One quick question on metal. So I've got a similar setup to you. I've got a MacBook, which has a graphics processor, a CPU, and a neural processing unit. And it's never clear to me running a Llama what I'm actually using.
Okay, I shall demonstrate that shortly. If it's not clear,
So metal's the API, isn't it?
so Olama and llama.cpp will auto detect metal.
Right.
And I'll pull it out for you because I'll run it in a minute and we can show that it actually really is using metal.
Okay, perfect. Thanks.
David, long time no speak.
Hi. Yeah, is there a benchmarking tool to measure the tops for a particular integration?
Good question. No, I've not been able to find one.
Okay.
So if you, actually, since you raised it, I'll have a look at the Orange Pi. This is the Orange Pi, which I'll be demonstrating. And it just simply states 6 tops, but it does tell you the quantization that, so sort of 4, 8, 16 bits. And I think the 6 tops is really, they're talking about 4-bit integer multiplications.
It's the integrated MPU, isn't it?
Yes, yes,
Look at
it
it
is.
there, right.
So you'll get these 6 tops with models which have been quantized specifically to this hardware.
Okay. So the reason I'm interested is because I have systems that don't have MPUs in.
Right, yeah.
So, for example, PCs which will have GPUs, but it'll be interesting to know or to be able to measure the relative performance because some of them have a Radeon card, others have NVIDIA.
I will be running a benchmark shortly.
Yeah, I will.
But it doesn't output tops to come back to your first question, unfortunately.
Okay. Right. Okay.
I'm
Thank you.
not seeing any further hands up, so I'm going to plow on to the demos, and I can be, feel free to interrupt on these demos. Right. So, first demo. So, read the installation requirements. I know it sounds silly, but if you're going to play with this, this is not, installing your average desktop app. You need to know what hardware you've got, what you're doing. So generally the installation requirements and instructions are pretty clear, but just make sure you read them. And I'm going to say it again, read the instructions again. We are in the business here of the bleeding edge of running stuff on your desktop. Your hardware will be different, so your installation may be different to what I'm doing. This field is ever changing. Every time I seem to run these tools, I get a new version. So they get updated every week or every 2 weeks. And so it is a very fast moving field. Expect to try different things. Some things will work, some things won't. You might get some really stupid outputs from your large language models. You might need to try something different. So, expect to have a play, try things out, expect issues. Right. So this is the first demo. And this is llama.cpp running on my Mac and this is command line only to start with. So I am going to go to a window. Hopefully you can see this. Maybe make that a bit bigger. Right. So I've read the instructions to install it on my Mac. And the instructions to install my Mac is brew install llama.cpp. And this is actually already installed. So unless there's been an update, it's telling me it's already installed. So this is a case of reading instructions. If you're using Windows, if you're using Linux, the installation instructions will be different. But the thing is, llama.cpp is a single binary, so it's pretty easy to install. Right, so I've got some helper scripts here just to save me typing, and I will go back and run it. So now I've just started up llama.cpp on my MacBook, and I'm going to scroll back just so you can see a bit better what's happened. So what's happened is I've run llama.cli, and I've referenced a name of a model. This is just a file name. So I've previously downloaded this file, stored on my desktop here in the models directory.
Peter, can you decrypt the parameters in that file name for us?
Yes, I can a little bit. So Gemma 3 is the name of the model.
Yep.
From Google. 1B stands for 1 billion parameters. So it's a small model. The IT, I don't remember right off now. The Q4 we'll touch on in a minute, but that's telling it's been quantized down to 4 bits.
Right. Okay.
And the DGUF is a file type.
Perfect. Thanks a lot.
But in general, you can go to Hugging Face, and before you download it, it'll give you a description what these models are. Of course, I could have renamed the file name, but now you'll see some things in here. Okay, Llama. Oh, there we go. Using device metal, Apple M1 Pro. So that's telling us that llama.cpp has detected the hardware. It knows I'm running the metal GPU, NPU combination, and it's going to make use of it. So this is going to be an accelerated run. The next thing we've got is some information about the file. So it's given us the Gemma 3, it's given us maximum context length and loads of, maybe interesting, maybe less interesting, but it's information about the file. We can keep scrolling down. It's got some information about how llama.cpu is being configured. And it's telling us a little bit about how the acceleration is going to be. It's going to be offloading 26 layers to the GPU. But, it's giving us good information that the hardware is being used. Giving us more information about the CPU type here, various parameters that may or may not be supported with either the model or the hardware, and so on and so forth. And eventually, down here at the bottom, we got a prompt. Yay. So at this point, we can type something in. Why is the sky blue? And this is our first example of a large language model running locally on my desktop. So you can see, judge the sort of speed it is. Perfectly useful, actually pretty fast, I think. And that is a 1 billion parameter model. If I were to run a bigger model, it's more likely to be slower. If I were to run a model which has got smaller quantizations, it might run faster. So, download the models, try different things together. Now, and we can carry on typing here, but we've all used these tools before. The point is now llama.cpp is now running on my MacBook. It's using accelerating, it's loaded the model, and it's responding to my questions. Now, another way we can run llama.cpp is in a server mode. And again, I've got a little helper to save me typing. It looks similar. I'll scroll back just to see, you can see what I've actually done here. I've run Llama server this time and specified a port number. It's actually the same output, but instead of getting a prompt, I get server is listening on that. So I can cut and paste that one. I can go to my web browser, I can paste that in. And now I've got a, make this a bit bigger, maybe a bit too smaller. So this is a very simple web interface to llama.cpp. So I can type in exactly the same thing here. Why is the sky green? And llama.cpp running locally on machine is replying, but instead of in a a text window, it's actually giving. Now we can see here it's gone wrong. And you'll expect to see this when you play around with stuff running locally. So here it's got itself into a bit of a loop. This is a 1 billion parameter model. And when I see things like that happen, it goes a bit wrong. It's probably a hint that I need to get a bigger model, get a more sensible response. I'm glad it did that because then you can see sort of things that you can do, can get wrong. Right, so that's llama.cpp. Now, before we finish, I'm going to try and get back to David's question. There is a tool, Llama Benchmark. Now, we can see here, I've run Llama Bench and I've given it several different models to run. So I've got a 1 billion parameter model, I've got a 4 billion parameter model, I've got a 12 billion parameter model, and a different type of model completely. Maybe I've made that a bit too small. And we can see some results here. So I've got the 1 billion parameter is doing, for this particular benchmark, 2000 tokens per second. And the 4 billion parameter one is doing 567 tokens per second. So, about 1/8 the speed. And in fact, this benchmark will take an awful long time to succeed because the 12 billion parameter models don't work well. Oh, well, I've got one there. There we are on that benchmark there. So I'll stop it there. So the 1 billion with quantization 4 bits, we've got 2000 tokens per second, the 4 billion parameter at 500, and the 12 billion parameter, well, nearly 200. So you can run this little simple benchmark, try different. And of course, this is just a simple pre-canned benchmark test. But hopefully that is some way to answer your question, David. So let me go back to our slides. All right, so this is llama.cpp and some examples, including benchmarks. So, as I said, sorry, David. Oh, you got your hand. Oh, gone away. Fine. So another command line tool is Ollama. Ollama is actually written in Golang instead of C. Again, it's a single binary. So it's nice because you don't have a whole bunch of dependencies to install. And this is the way you run Ollama. You have to run it in client server mode. So first of all, you have to run Ollama serve, and then you've got the client, which you can list the models and you can run things. But yeah, demos are much easier thing. Let's just do the demo. So we need 2 windows in this case. Just resize them a little bit, a bit more room. Right, so on one window, we're going to run the server part. Start Ollama. This is a bit simpler, and we can see we just run Ollama serve. And in here somewhere should be a clue that we are running on metal.
Okay.
Always good to check that. And in another window, we can run a client. So we can run Ollama list. to list the models that it's got stored. And there's the list of models. So we got, these are ones I've already downloaded. So, Gemma 3, Llama, Mistral, and so on and so forth. And we can run some inference. Llama, Llama, run. And let's pick a model. I don't know, let's pick that one there. Takes a little while to load the model. So you can see the server part doing some stuff. And finally, we got a prompt on the client part. What is a nice Greek island to visit? And again, so this is Llama running on models, in this case, a different model, Llama 3.2, and it's running on our desktop with acceleration, metal acceleration. So a slightly different way to run it. It always works in the client server mode. Now, Llama.cpp and Ollama do pretty much the same job, but Llama.cpp does support a bigger range of hardware. It's more advanced in that sense. But Ollama, what we're just running here, is got more user-friendly features. So we can ask it to download models. We can choose which model we want to run. So, I run Ollama all the time. That's the base of it. But Ollama does support slightly less hardware than Llama.cpp. So I think most people will be running Ollama, to be honest. Okay, any questions so far? Oh, so let's quit out from the client here. Go back to the slides. David.
Right. Yeah. Thanks for showing the measure. I mean, that will give a basis for comparison. My next question is, I noticed that as part of the setup, it offloaded some of the layers of the model to the GPU.
Yes.
Now, I guess I have two questions then based on that. One is separation of layers the only basis for distributing the model? And if you have multiple nodes in your local network, can you distribute the model and its execution across those nodes?
Yes. So the first question is, how do these inference servers actually offload stuff? So actually the mechanism to offload to an NPU and a GPU is slightly differently. So if you offload to a GPU, it makes use of the GPU memory. So if you've got a large model, ideally you get a GPU with a lot of VRAM so it can hold more of the model in memory at the same time. But benchmarking, if you try to run a too large a model on a GPU, you can find it spends too much time copying the layers up to the GPU, running it, and then copying the results back, and you can thrash this way. The NPUs tend to work differently. They tend to work with linear memory, so they can get different results. So it's worth trying it ultimately. But the other thing worth saying is that models are often optimized to hardware. So if you've got a GPU that's got, let's say, 2 gigs of RAM on it, you probably want to choose a model where the layers are about 2 gigs in size. If you have layers which are too big, it's not going to fit into the GPU and it's going to run slower. So we're definitely in the business here of, let's say you want to run the Google Gemma 3 model, picking lots of different variants of that model, which is quantized in different ways and different number parameters, and just see which one works best on your hardware. But it is a little bit of a black art at the moment.
Okay. Okay. So that also suggests it's not going to be easy to distribute the execution.
Oh, yes. Sorry.
model across.
Yes, absolutely. There are ways to distribute model inference across several servers. I've never tried that and I've never actually looked into doing that, but I do know it's possible to do so.
Okay.
And I think that's going to apply mostly to things like diffusion models. Because if you've got a large language model, it's going to be hard to do part of the inference on one server and the next part on a different server. It's
Okay.
more easier on a diffusion type model when you're iterating through the images. Right, okay. So let's go back to our slides. Now, hopefully this is keeping up. I was a bit worried about, jumping between command line and graphics might be a bit confusing. Right, finally, we get onto the graphics side of it and we're going to run Open Web UI. So we're going to run Open Web UI. And first of all, we're going to get Open Web UI to connect to Ollama running on my desktop. So let's do that. So we have here Ollama already running, which is good. Now I've got a nice little, again, if you want to run this stuff, read the instructions. Start Open Web UI. Now, Open Web UI is written in Python, and I know I've said this before, but I'm not a particular fan of Python. One of the problems of Python is that each application comes with about 20,000 dependencies, and those dependencies can differ between different applications. So actually what Open Web UI recommend, and I'll scroll back here a bit, is to use the UV tool, which is a way to create a Python environment just for this application. So all I've done here is just do a cut and paste from the installation guide here to run the web UI. It's come up with it takes a little bit of time to start. It is still starting up, unfortunately. So we'll just wait for that to start up. And hopefully this will still work, because as with the other tools that I'm running, this does change on a daily basis. So this is our nice, friendly open web UI. And actually supports multiple users. It's got a whole bunch of administration configuration. So if you're running this at home for several people on your network, it's probably a good choice. You can give different people different logins. Peter, sorry, I didn't notice you got your hand
I've
up.
got an issue like the other chap had. All of a sudden, I've got you in the full picture, and I've got the thing in the bottom right hand corner. It's quite
Right.
interesting. I don't know
Let me,
what's happening there. Similar sort of thing as he had earlier on.
okay, let me just restart sharing, and thank
Sorry
you.
about that. Thank you. That's
Is that-
okay now. Thank you.
Okay, yeah. There's something odd going there. I'll just have to stop and restart sharing. Just let me know if it happens again. So, um, so this is Open Web UI starting up, and it's giving us a whole bunch of information. So if you remember, we got a web browser, we got Open Web UI, and then we got Ollama. So Open Web UI knows about Ollama by default. There's no configurations needed. And straight away, you'll see in the top here, we've got a list of different models that it supports. This is directly from Ollama. So Open Web UI has done an Ollama list. And so we can just choose whatever model we want to use. Let's use Gemma. Why is the sky blue? And so the web browser is taking what we've typed in, sent it over to Ollama. Ollama has done the staff and displaying the results. You'll notice this time we've got bold, we've got indentations, we've got links, and so on and so forth. So there's a lot of conversion plain text to markup to rich text, make it a bit more usable. And we can create new chats, we can choose different models and so on and so forth. Now we can not only talk to Ollama, and in fact, let's stop Ollama in the background there. let's done start llama.cpp. So now llama.cpp is running as a server. OpenWebUI doesn't automatically detect it, so we're going to have to tell it. So we can go into settings, we can go into connections, and we can add a connection. So this is just a URL, and you'll see that's actually what it outputted there. You have to add the B1 on it. We can test to make sure it's running okay. Good. And we can enable that inference engine, save that. And now we can go into select model. We're now, oh, let's do a new chat, select our model, and now we're running llama.cpp. And there we are. So we've got the same user interface talking to a llama and talking to llama.cpp. In fact, you can have them both running at the same time if that's what floats your boat. Okay. So let's do something a bit different now. Why not? Going back to the slides. Yeah, there we are. Right, Orange Pi 5. So let me, what I'll do actually, I'll stop sharing. And hopefully you might need to make me a bigger icon. So this is my Orange Pi 5. And we've got, it's live, it's run. I've got Ethernet cable there, power supply there. It's got a big heat sink on top. I know you can see it's got the chips in it on there. You can see underneath there. This is like a fast Raspberry Pi, if you like. And it's got 16 gigs of RAM. It's got 6 TOPS NPU on it. What I like about these sorts of devices is you can have them running on your home network all the time. You can use them to host your home automation, your web servers, file servers, backup systems, whatever you like. And hey, we can use these to run large language models. So let me start sharing again. Now you've actually physically seen that. Share my desktop again. Right. Now, you might see a little bit of a difference here. So again, I've got a little wrapper and script, start. Okay, so it's actually running a inference engine on my little device here, SSH to it. I'm running this particular command and giving it a Gemma 2 model with 2 billion parameters on it, which has been optimized for this hardware. So if you go into Hugging Face, a little bit smaller. If you go into Hugging Face, you will see models with RK3588, and that's the name of the chipset on these devices. And those have been optimized for the hardware features here. So let's switch over to where are we? There we are. So we can go into our OpenWebUI. We can go into our settings. We can go into connections. What we'll do is we'll disable the one we're using just then. And I will enable this ARM6. This is the name of this little server here. I can check to make sure it's working. Yep, it's working. I can enable that. Okay. Yes, go away. Right. So we've only got one model we can run, DeepSeek. And so this is running on this little tiny device that you've just seen. It consumes, 1 watt of power usually. It does spike when you're running these things, but why is the sky blue? See if you can notice any difference in the performance. So you can notice it's quite a bit slower than my desktop, just as the way it's running step by step. But it really is running on this little tiny server here. So you can have that running all the time in the corner. Now, and you can run one of these GUIs. You can have your home automation use it. You can use it in your text editors, whatever you like, because it uses the same standard API. So possible to do it, but it's going to be a bit slower because it can only do these 6 tops. Right, so that's running on a little tiny device. As I say, a little bit different. Right, what else do we want to do? Let's go back to our slides. Orange Pi 5, got some information about them. Right, diffusion models. Diffusion models is about generating images. So what I'm going to do on my desktop, I'm going to run a diffusion model from automatic 1111. And then I'm going to use the web UI interface to actually interface to it. Let's just do that straight away. Where am I? Start stable diffusion. So this is our inference engine, which is designed to run diffusion models. And again, it's given us a little reference, a link in here. Somewhere in here, we can see that it's detected the hardware. Now, we'll give you warnings here. This is significantly slower than running text prompts. So again, let's go into our settings here. I know what we need running as well. We also need the llama running. So let's go into our settings. We will disable the one from our little Orange Pi here. And this time we need to go into our admin panel, settings, and we've got images here. And we can enable image generation. And this is, say, the configuration from last time I was using it. It's talking to the little server I've just started here, automatic 111. I can just check to make sure that's working and save it. So now you'll see something a little bit different here. Now in the web UI, I've got a little icon here, generate image. I can click on that to enable it. I can pick a large language model. So I'm actually going to be running here both a large language model and a diffusion model. Let's say Greek island sunset. Here, and this will take a bit of time, I'll warn you now. But whilst that's running, you can see I've got generating an image here. We can see the server side of it is starting to fire up the diffusion model. And it will take a while. Now, because this is going to be slow, it's probably a good time to ask any questions if you've got any or points to raise. Okay, but yeah, there we go. It's going through. And it's generated an image, not a very good one, but it has generated an image. Now, what I've got here is I've pre-configured the diffusion model to run in 5 steps. The default is 10. I've done it for 5 for demonstration purposes. If you're going to do, half decent pictures, you'll probably get it to do 50 and make a cup of tea while it's producing the image. So this is the web UI interface in both a large language model running locally and a diffusion model running locally to generate an image and give us text back. Peter.
Oh, a second. Do you have an example, without breaching any confidentiality, of a model which you generated for your own use at all?
How do you mean generated for your own use?
Well, you did one some time ago, which was the identifying the birds. That was one thing you did, haven't you? Or the animals in the garden.
Yep.
Have you? I guess I'm asking, have you ever done a model, for example, of all your correspondence or stuff? I don't want that breaches confidentiality. The problem of this question, but have you got anything at all which might be a model which you actually produce yourself rather than downloading a model?
Yeah. So the birds and animal talk I did was a non-generative model.
Okay.
So it didn't have all these layers to do the large language model stuff. It was
Okay.
just a very simple neural network, and those it was perfectly possible to train yourself on, home hardware you can buy. In fact, those trainings were complete overnight. In the morning, I had a new model to try and test. Large language models, Chat GPT 3 used 1,024 GPUs to train, and it took 34 days and costs $3 million. So training these large language models is not really something you do at home unless
But
you.
if I had a whole bunch, you mentioned if I got a whole bunch of PDF files
Yep.
and I wanted to put it into a language model to see what it could do to help me self-organize at home, you're saying I can't do it. Is that what you're
No,
saying
no,
to
no,
me?
you can. Yep, yep. We'll but you see in this picture here, we've got a plus sign here.
Yeah.
You can actually upload files. So let's try this. Actually, turn off image. I will look for a model called Lava. Let's do a new chat just since you're Lava. Actually, Gemma 3 does it as well. So I can upload a picture. So this is the multimodal large language models that's been trained on images and text. Describe this picture. So absolutely, with multimodal models, you can use the UI to upload pictures and get the large language models to failed to usually describe what these are. We'll try it since you asked the question. Lava is the one I normally use for this. And similar technique for if you're doing PDFs. I don't have any PDFs here, but you can upload the picture and then upload the PDF and then ask questions about the PDF. You just need a large language model for that. You don't need a diffusion model or a multimodal model to do that. But you do need the right plugins into the web UI to interpret PDFs.
Okay. Thank you very much indeed. Thank you.
Okay. So that was diffusion models. Let's go back to our slides. Let me stop, and you can play around with this. And honestly, this is that's one that took a bit of time. That's a bit, perhaps a prettier example of the sort of results you can get. Right. Let me stop that. Keep Olama running. Let's see what we've got next. Okay, so there is this thing of tools. Now, tools is a feature of large language models that requires cooperation between both the client and server. So the model needs to support tools, as does the client that you're running. In this case, it's web UI. One example of a tool is web searches. So large language models by themselves aren't internet connected. They've been trained up to a particular point in time. So they're not going to know, who the current president of the United States is. But if you enable web search is as a tool, you can get your web UI to do its own web search and then feed the results down to the model, and then the model will use that as part of its data. Let's just do the demo. So get rid of that. I think I'll stick to my standard one. To do that, let's go into our admin panel. What we'll do first is I will disable images because I've already stopped it. And we've already got a built-in tool called web search here. And we can enable a web search tool. And I've already pre-configured it to use my own personal search engines, but you can use, you can use Google or Yahoo or Bing or a series of options there. Now if we got a new button here, web search. So what happens now is when we type something in, the Open Web UI is going to use a tool to do a web query first, get the results back from that, and then give it to the large language model. So oh, hang on. Okay, let's do who is the president? Now, if I hit go here, you'll see something different here. It's doing a web query here first. And this is this idea of plugging a tool in. This is going to take a little bit of time. It's reaching out to the internet, doing a query. In fact, what it's doing several web queries in parallel. We'll come back in a minute. Oh, there's the, let's get rid of that one.
Peter, can you see what queries it's actually sending?
Yes, you can. I'm just showing you the page now. Fetching pages. Maybe you need to enable a bit more debug here. Okay, looks like it's got the responses back. Maybe something's not going quite right here. It's taken a bit of time. Usually this should be pretty quick.
Maybe he's resigned.
Do you know what? I'm going to stop that and try it again. Okay, I don't know if you can see this, but you can see some output here from the web UI. So it's searched 9 sites. And the current president of the USA is John Trump, apparently. It's given us some references here. Oh, there you go. It's giving you the web pages it searched to answer your questions. So there we go. So this model was trained before Donald Trump was made president, but we've augmented the knowledge, if you like, of the model with doing a web search and give it some more information. So you can, type in any question you like, find me a villa in the south of France to book for next week. So there's a whole bunch of tools you can install on Web UI to do different things. You can get it to do querying stock prices over a period of time and a whole bunch of stuff. So, you can do that for your homework to see what else you can do. Right, so what we're doing for time. We're doing pretty well, just sort of rounding up really. So that's web search. Some examples. So here's something you actually really might want to do. If you're doing home automation, like Home Assistant, you might want to plug in a large language model so you can extend it to reply to you in a more English way. So Home Assistant's got an Ollama plugin, so we can plug in that. We can give it the address of where Ollama is running. We can choose a model which has to support tools. We enable it in Assist, and we can expose some entities. Let's just do the demo. Again, let me know if you're not seeing my Home Assistant. So what have we got running? We got Ollama still running. We got our web UI still running. This is our administration page for Home Assistant. So what I'm going to do, I'm going to go into Settings, Devices and Services, and I'm going to add a new integration, which is Ollama. And we need to give it the address of where Ollama is running, which I will do. I'll choose a model, and I'll stick with Llama 3.2, why not? Okay, so that's now configured. Now we need to go into our chat settings, add an assistant. We're going to add in our new one. Let's call it Llama. So now we've got two chat assistants on Home Assistant here, and we can use either one. And here we've got what entities, what pieces of hardware we're allowing Home Assistant to control. So we can go into the chat. We can either choose Home Assistant as a chatbot. Actually, let's do that first. Let's use the built-in one. Why is the sky blue? So the default chat assistant, not a large language model. It's got no idea what I'm talking about. But if we switch it to Ollama, why is the sky blue? That request will now go over to our large language model running locally on my desktop, and it's given us a response. But of course, we can do a little bit more. We can ask it about sensors because it's got these tools plug in. What is the value of the, make it a bit bigger, of the air quality temperature? It's telling us outdoor temperature is now 27.7 degrees. I've got a little sensor outside. Actually, before I do this, let's go on here. I've got a little switch here, which is actually on my air fryer. You keep an eye on this guy here. I choose that, and I'm going to ask it to turn it on, turn it off. Turn smart plug one off. And large language models, because it's got the tools built into it, can then go into Home Assistant and actually control your hardware. And well, turn smart plug one on, and we can see it's toggled in the background there. So you can run Ollama locally on your network, get Ollama to load your model. You can use it with web UI to add ad hoc queries and responses, and you can also hook it into other tools. In this example, hook it into your home automation. So we are pretty good for time, and we are really at the end now. There's Home Assistant model. There's an example. Oh yeah, let's do this one for fun. Large language models talking to each other. I suppose you've got to do that, haven't you? Last demo, start two large language models. This is a really silly Python script. And what it does, it makes two connections to Ollama and gets two large language models talking to each other, A and B. And they can go and talk to each other forever. Sort of thing might be interesting to do if you want to do a demo. I don't know why I chose to do that, but there we go. And that's going to go on forever until you stop it. Two models talking to each other. And some other further bits and pieces, just rounding off the talk now. So I've only really scratching the surface, right? There's a whole bunch of stuff. If you're into this, you can, download these tools, download the models, or get the tools to download the models for you and have a play. So models are pre-trained, so they don't know about recent events, but you can use actually what's called RAG, local retrieval augmentation generation, to either upload a document or do a web search, which we've talked about it. You can try these tools to do different things. I mentioned we saw Home Assistant tool indirectly. You can, also tools there to query stock prices. Maybe you want to say, what stock should I buy next week? Try models with different quantization settings might suit your hardware better. And we did have this question, is what these numbers stands for. So if you've got a very high quality model, they are probably going to use things like BF32 or BF16. They're going to have that in the file name. Those are very high accurate sums in the model, but you're going to need lots of hardware to be able to run those models. We can have 8-bit and 6-bit quantizations level. 4-bit seems to be about the sweet spot for running on desktops. So to start with, you probably want to download models that's got Q4 in the file name. And we can actually run 3 and 2, even 1-bit numbers as well, which is really fast, but going to be less accurate, less reliable. Try a mixture of expert models. These are models with large number of parameters, bigger than you might be able to run, but each time you do a query, you're actually only running a small part of the model. So you might have better success with those. Now, I'm going to finish with this. We've talked about large language models, which is about taking text and producing text, and large language models have this event loop that goes around in circles, does this next token prediction. We've talked about diffusion models that generate images, and the way they work, they start off with a picture, which is just random noise, and they go around the loop, getting more and more accurate on the picture to finally decide to stop. We've got some sort of picture left. There is now a new thing which is combining these two models together called diffusion large language models. And this is probably the future of running generative AI at home quickly. Now, I can't demonstrate it yet, but maybe in 2 or 3 months you might be able to do this. But I've got a little demo of it. When I run this demo, on the left side here, we'll be running a query on a large language model. And on the right side here, we'll be running the same query, but on a diffusion large language model. And you see the difference. So if you notice that, I can play it again if you like. But the large language models started off outputting word by word by word by word. The diffusion model outputted word of random orders, and the diffusion model is quite fast. So this one here, this slow one on this side, word by word. This diffusion model is doing it at random points in the output and significantly faster, 14 versus 75 iterations. So I'm hoping sometime soon we'll see Olama and lava.cpp supporting these diffusion large language models, and also the web UI supporting them, and we should be able to do queries significantly faster at home. Last page, references as normal. So that's it for today. Anything for anyone else? Any questions, points to raise?
If you've still got time, Pete, I'd be interested in how you load tools into Alarma. I've just fired mine up and had a quick look. I don't immediately see it, but I'm trying to work it out.
Yeah, you do it in the web UI.
Yeah, I'm in the web UI and I've got to the tools bit. So it's taken me to the GitHub repository, so I just need to work my way through that, I assume.
Sorry, no, so it's in settings, admin panel, settings, and we got tools here.
Yeah.
And you can add a tool. And I believe what you need to do is have a look on the web UI page, and they've got lots of examples there.
Okay.
So it's got some default pools, web service, code executions, images that we saw, pipelines, databases. I don't know if we can actually find it. Oh, there you go. Open Web UI tools. There's your homework for the weekend.
Okay, sounds good.
I haven't actually tried this beyond what I've demonstrated. Anyone else for any comments, thoughts, points of view? Nope. I'm not seeing any. Oh, got something in the chat. What have we got in the chat? Oh, just a thank you. Okay, stop sharing them. Okay, so thank you for coming today. I hope it's been useful.
Very good.
So next week we'll probably do installing Linux, just because I've got that ready, all prepared. And it is the festival season, so we're all busy on our festivals. Okay, so see you in a month's time. Thanks.
Right.
Okay, thank you, Peter.
See you later.
Okay. Yeah, thanks, Peter.
Okay, no problem. Bye.